The next topic is the asymptotic notations. Asymptotic notations. So we are going to use three asymptotic notations here. Number one, the big O notation. Number two, the big omega notation. And number three, the big theta notation. We have three notations to compare the programs. One is the big O, which is also called as big, also some people call it as big O notation, and this is big omega, and this is big theta notation. Okay, so we have big O, big omega, and big theta. So let us go through what is a big O notation, and we'll see. So these asymptotic notations are also used to measure what is the rate of growth of a function. Now this is important to understand. We are saying the asymptotic notations are going to measure what is the rate of growth of a function. Now let us say we have two functions. We have a function fx, or let me make it fn. We have a function fn and a function gn. Now we are going to compare these two functions on the basis of the rate of growth of these functions. So for the first measure we are going to use what is the big O notation. Big O, it is important to understand what is the big O notation. Let us suppose we have the function fn and gn, and this is the graph, and here we are increasing the value of n, and here the function's value is increasing. Okay, now let us say this is the graph for the function which is fn. Okay, and this is the graph for the function which is gn. Okay, and this is the point which is n naught. This is some point n naught. That means after this point gn is always greater than fn. Let us suppose we have these functions, and we can also give this as gn as c dot gn, which we are going to see what is this c dot gn. Okay, now what does big O notation says? It says if we can say that fn is always less than or equal to c dot gn for all n greater than n naught, then we can say that fn is order of gn. Then we can say that fn is order of gn, where c is a constant and n is some value on this and naught is some value on this n. Okay, now what does it mean? It means if you see in this graph, after this point n naught, gn is always greater than fn. Gn is always greater than fn. That means fn is upper bounded by gn. Fn is upper bounded by gn. That means the upper bound to fn is gn's. It means whatever the maximum value of fn can take, whatever the maximum value fn can take, gn will always be greater than fn to that. After this point gn will also be greater than fn. Right? Now before this point n naught, their values can fluctuate. It may happen at some point of time fn is greater than gn. It may happen at some time gn is greater than fn. That is, before this point their values can fluctuate, but after this point Gn is always greater than Fn, then we can say Fn is order of Gn, where C is a constant. Okay. So this is a Vigo notation. Let me take an example here. Let us say we have the function Fn is 10x square, or you can say it is 10n square plus 10n plus 100. Okay, and we have the function Gn as n cube. Now what do you think? Can I say Fn is order of Gn, or can I say Gn is order of Fn? We have two things. Can I say Fn is order of Gn, or can I say Gn is order of Fn? Which one of these statements is true? Okay. Now here you can see what are the values. It is Fn is 10n square plus 10n plus 100, and Gn is n cube. Now can I say which one is greater? Okay. So let me write it here. Let me just take some dummy values. Let me compare their values. This is Fn and this is Gn, and let us suppose these are the values of n. Okay. Now I am saying when the value of n is 1, then what is the value of Fn? Now see, I have added one more thing here. It is C. Now let the constant C is equal to 1. Okay, that means this, we are ignoring the constant, we are making the value as well. Now when I say n is equal to 1, then what is the value of Fn? Fn is 10 into 1 plus 10 plus 100, that means 10 plus 10 is 20 plus 100 is 120. And what is the value of Gn? The value of Gn was 1 only, because 1 cube is 1. When I say the value of n is 2, in that case what is the value of Fn? Fn became 10 plus 4 into 4 is 40, 40 plus 20 plus 100, which is equal to 160. And what is the value of Gn? Gn is 8. Now if the value of n is 3, then what is Fn? Fn is 90 plus 30, which is 120, 120 plus 100 is 220. And what is the value of Gn? Gn is 27. Now in the same way, if I go to some point, let us suppose we have the values as 10, the value of n is 10. Now this statement became 10 into 100, which is 1000, 1000 plus 100 plus 100, which is 1200, and Gn became 1000. Now let us just increase the values to 20. Okay. Now if the value of n is 20, then this became 400 into 10 is 4000 plus 200, that is 4200 plus 100, that is 4300. And now what is this value? This value became 8000. Take any value bigger than 20. This Gn will always greater than Fn. You can see the see before this point here, if I taken the value n as 1 to 10, Fn is greater than Gn till this point of time 10. If I take some value, let us suppose the value of n is 11, then Fn becomes 100, 10 plus this value becomes 110 plus this value becomes 100. Therefore the values become 1420, and the value of Gn becomes 1331. Right? So you can see, if we are going from this point to this point, these values are getting close to Fn. At one point of time Gn was greater than Fn, the difference was huge, but as we are going, the difference is getting reduced. Gn is growing faster as compared to Fn, but after some point of time, let us suppose the value of n became somewhere around 13 or 14, maybe 13 or 14, then after that point of time Gn will always be greater than Fn for C is not equal to 0. That means Gn, if you take any value here, Gn will always be greater than Fn. That means Gn will always upper bound Fn after some value. Now let us suppose that value is 20, right? So after that value Gn will always be greater than Fn, but before that values, that point their values can fluctuate. Before that point their values can fluctuate. Okay. Now let me say, if I increase the value of C, then if I increase the value of C, now let C is equal to 10, then what will happen? Then this is Fn, this is Gn, and this is the value of n, and we are talking about the same function. Now if the value of n is 1 and Gn will be 10.Gn, then Fn will become 120 and Gn will become 10. If the value of n is 2, then Fn will become 160 and Gn will become 80. If the value of n is 3, then Fn will become 220 and Gn will become 270. If the value of n is 4, then Fn will become 160 plus 40, which is 200 plus 100 is 300, and Gn will become 640. In the same way, if you increase, now by taking the value of C, by taking this constant C, you can see this point has shifted. Now if you see this point, if you see this line, after this point which is n is equal to 3, Gn is always greater than Fn, where C is equal to 10. That means with the help of this C constant, you can shift this point in both the directions. If you take the value of C is very big, then this point may shift to this direction. If you take the value of C small, then this point may shift to this direction, but this point will always exist. The only thing which you can do with the help of C is you can shift these 2 points into these 2 directions. Okay, so this is the big O notation. Let me take some more examples to clarify the concept here. Okay, let me just rub this up. Now let us say the value of Fn is 1000 n square plus 1000 n plus 1000. The value of Gn is n cube. Now can I say Fn is order of Gn, or can I say Gn is order of Fn? Which one of these statements is valid? Okay. Now see here, what is the value of Gn is n cube and the value of Fn is 1000 n square plus 1000 plus 1000. Okay. Now the concept is asymptotic notation. It is going to tell what is the rate of growth of a function. That means out of these 2 functions, which function is growing to which function is having more steep growth as compared to the other function. Okay. Now what I am saying is, let us say we have here in this case, let us assume some values. Let us say this is Fn and this is Gn, and let C is equal to 1, and this is the value of n. Okay. Now let us say the value of n is 1. Then this value will become 1000 plus 1000 plus 1000, 3000, and this value will become how much? 1 only. If I take the value of n is 2, then this value will become 4000 plus 2000, 6000 plus 1000 is 7000, and this value will become 8 only. Now if I increase the value, let us suppose the value of n is 10. In that case, this value will become 10 into this is 100 plus 1000 is 1 lakh, 1 lakh plus 10,000 plus 1000, that is 111000, right? And this value will become 1000. Now if I increase the values of n, let us suppose the value of n will become 100, then this value will become how much? This will become 100 into 1000 is, oh sorry, so it is 100 square into 1000 is this much and this much, that is 1 times 100, so it is 1 million. and this value will become how much? This much, and this value will come this much, right? So what is the value? 1010100. So this value became this much, 1010100. And what is this? The value of Gn. Gn became this much. You can see the values are getting closed, right? So here 6 and this is 7. Now if I increase the value, let us suppose the value is 1000. If the value of n is 1000, then what is this value? This value will come this much. This value will come this much. This value will come this much. Therefore the complete value is 1001001000. So it is 1001001000. And this value will come how much? It is 0000000. How many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is again 9 zeros. See, this value is getting close to this value. Now if I take even the value 1001, even if I take this value, then this value will be less than this value. If I take any value greater than 1000, then this value will always be greater than this value. You can test this. If I take even, let us suppose we take the value as 10,000, then this Gn is always greater than Fn, right? Now in that graph which we have seen, this graph, right? So what was the graph? It is Gn, it is Fn, and we can write it as C dot Gn. And you can see this graph is open on this side. That means the value of n can go to infinity. Here n is tending to infinity. That means n is tending to infinity, which is n tending to infinity. Now when n is tending to infinity, then you can see Gn will always be greater than Fn after this point. If I increase the value of C, let us suppose let C is equal to 100, then you can shift this point to this direction and Gn will still be greater than Fn. But here I can say that Fn is order of Gn, but I can never say that Gn is order of Fn, because Gn will always be greater than Fn after some point of time, right? So here you can observe in any function, for example in the same function, here the highest power of n was square and here the highest power of n was cube. Now in these any two functions, if one function is having a bigger power, then the other function will be order of that function. Let us suppose here if the power of Fn is n square and the power of Gn is n cube, it is cube, it is square. Even if these statements are very big, does not matter, but because the power is greater, therefore you can always say that Fn is order of Gn in this case. Fine. Let me take more examples here to clarify the concept. Now let us say Fn is 100 n square plus 100 n plus 100 and Gn is n square. Now in this case, can you say that Fn is order of Gn, or can you say that Gn is order of Fn? Okay, Gn is order of Fn. Now in this case you can see if this is Fn and this is Gn and let C is equal to 1. If the constant C is equal to 1, then you can clearly observe that Fn will always be greater than Gn, right? That means here you can say Gn is order of Fn. Now if I say the value of constant is 100, in that case also Fn is greater than Gn. If I say the value of constant here is 1000, then you can say that Gn is greater than Fn, or even if the value of C is 101, then also Gn is greater than Fn. In that case you can say Fn is order of Gn, right? Now in this case the highest power is same, because in these two functions the highest power is same, therefore we can say that Fn is order of Gn. In the same way Gn is order of Fn, and how you can make it just because of the value of C, the constant C, Okay, we'll discuss about the specific examples in more details whenever when we are going to study this omega notations. After the omega notations, I guess this thing will be clear to you, and you'll be very happy after this. Okay, so I'll make you a happy person, right? So now let us discuss why we are studying this. A short, a small, simple example. Now let us say we have the function fun, which is having int n. Now you can say you have for I is equal to 0, or make it I is equal to 1, I less than n, I plus plus, printf hi. Let us suppose we have this function. Okay. Now you do not know what is this value n. You can say how many times I am ignoring this statement. I am just saying how many times this statement will be executed. It will be executed only once, right? How many times this statement will be executed? How many times it will be executed? It will be executed how much? N plus 1 time, or not n plus 1. It will only be executed n times. How many times this statement will be executed? Only n time. How many times this statement will be executed? N minus 1 time. So in total, how many times they are executed? They are executed 1 plus n plus n plus n minus 1, which is basically equal to 3n statements are being executed. How many? 3n. And these 3n is basically dependent on the value of n. You can make it as fn is equal to 3n. When the value of n is not given, you can represent the number of statements which are being executed with the value, with the function which is fn. Now there are 3n statements are being executed. Now let us say gn is equal to n square. Now can I say that fn is order of gn? Yes, definitely I can say that. I have already told you that the power of gn is greater than fn. I can definitely say that fn is order of gn, right? If I say we have hn, the value of hn is n cube. Now can I say that fn is order of hn? Yes, I can definitely say that because hn is greater than fn. If I say xn, which is n raised to power 4, can I say that fn is order of xn? Yes, I can definitely say that, right? What does it mean? It means that in the graph, if this is a function fn, this is a function gn, this is a function hn, this is a function xn. I have not drawn specifically for this example, but let us say, because here it will be having some curve like this, but I have drawn something like this. So just see, these are these functions. Now you can say, see, gn is greater than fn, therefore fn is upper bounded by gn. hn is greater than fn, therefore fn is upper bounded by hn. xn is greater than fn, therefore fn is upper bounded by xn. All these functions are greater than fn. That means there are more than one upper bounds which are existing. Yes, there can be infinite number of upper bounds. There can be infinite number of upper bounds. But out of all these upper bounds, we are not interested in them. We are not at all interested in all these upper bounds. We are only interested in something called as tightest upper bound. Tightest, I don't know what is the spelling of tightest. Okay, so tightest upper bound. So we are only interested in knowing what is the tightest upper bound in all the upper bounds. Now what will be the tightest upper bound of fn is equal to 3n? We have fn is equal to 3n. For this, what is the tightest upper bound? Think, if I say gn is equal to n, can I say that fn is order of gn? And you can see here clearly, we can see this, we can say this, because we can take the value of c constant as, for example, 4. We can take the constant c which is greater than this, therefore gn will be greater than fn. Hence we can say that fn is order of gn. We can definitely say this. But in this case, But in this case, this is the tightest upper bound as compared to the other upper bounds. So this is the tightest upper bound. Fine. So in the case of upper bounds, in the case of lower bounds, we will not be interested in all the upper bounds. We will be only interested in what is the tightest upper bound. Okay. Now let us see what is. Now I guess you have some idea about what we are doing here and how we are going to relate all these things to this program or other programs. Now let us see the lower bounds, which is the big omega notation, and then after seeing the big omega notation, we will see the big theta notation. Then we are going to see some programs and how these concepts are being implemented in those programs. Fine. Okay.